For most of human history, the stars seemed impossibly distant. They appeared fixed in place, permanent fixtures of the night sky, separated from Earth by vast oceans of darkness. Although civilizations imagined journeys between the stars, reality suggested otherwise. The distances were too great, the spaces too empty, and the boundaries between solar systems seemed absolute. But modern astronomy has revealed a different picture. The galaxy is not a collection of isolated islands. It is a dynamic environment where stars are born, planets form, and countless fragments of material travel through interstellar space. Occasionally, one of those fragments enters our cosmic neighborhood. These visitors do not arrive with dramatic explosions or brilliant displays. Instead, they appear first as faint points of light moving against the background stars. At first glance, they seem unremarkable. Only after careful analysis do astronomers realize they are witnessing something extraordinary. Unlike ordinary asteroids or comets bound to the Sun, these objects follow paths that cannot be explained by our solar system alone. Their trajectories reveal that they originated elsewhere, traveling through the galaxy long before their brief encounter with Earth. Recently, powerful space-based observatories have allowed scientists to study one of these rare interstellar travelers in unprecedented detail. For the first time, researchers were able to examine not just its motion but also clues hidden within its surface and composition. What they found was fascinating. Rather than appearing smooth and uniform, the object displayed signs of a long and complicated history. Its surface reflected evidence of countless impacts, exposure to cosmic radiation, and gradual alteration over immense spans of time. Every mark seemed to tell a story. Every feature hinted at a journey lasting millions, perhaps billions, of years. This was not simply a rock drifting through space. It was a surviving fragment from another planetary system. As astronomers analyzed the light reflected from its surface, they identified materials commonly associated with the formation of planets and smaller bodies. Frozen compounds, rocky minerals, and carbon-based molecules appeared among the detected signatures. These substances are familiar to planetary scientists. They are the same fundamental ingredients found throughout our own solar system. That discovery carries an important implication. The materials required to build planets are not unique to our corner of the galaxy. Similar chemical processes appear to occur around many different stars. In other words, the ingredients that helped create Earth may be common throughout the Milky Way. The visitor seemed to confirm a growing realization among astronomers: planetary systems may share far more similarities than previously believed. Its appearance also suggested something else. Rather than being a single solid block, the object may consist of multiple pieces loosely connected by gravity. Such structures are sometimes described as rubble piles, collections of fragments assembled through collisions and gravitational interactions. If true, the object survived an extraordinary journey despite its fragile nature. For countless ages it drifted through the darkness between stars, enduring extreme cold, energetic radiation, and occasional impacts from microscopic particles moving at enormous speeds. Yet somehow it remained intact. Now, after traveling unimaginable distances, it had entered our solar system for a brief visit before continuing onward once again. Its presence offered scientists a rare opportunity. Most information about distant planetary systems comes from indirect observations. Astronomers study stars, measure planetary motions, and analyze faint signals traveling across space. An interstellar visitor is different. It is physical evidence. A piece of another system arriving at our doorstep. For a short time, humanity is able to examine material that formed around a completely different star. And that changes the way we think about our place in the cosmos. The boundaries between solar systems suddenly feel less permanent than they once did. The galaxy begins to look less like a collection of isolated worlds and more like a vast interconnected network where matter, chemistry, and history move continuously from one region to another. The implications of that realization are only beginning to be understood. The arrival of an interstellar visitor raises a question that is both simple and profound. How many others have passed through our solar system unnoticed? For most of human history, we lack the technology to detect such objects. Even today, finding them is extraordinarily difficult. They are often small, dark, and moving at tremendous speeds. Against the vast backdrop of space, they can remain invisible until they are already passing through our cosmic neighborhood. The few that have been identified may represent only a tiny fraction of a much larger population. Astronomers now suspect that countless interstellar objects drift through the Milky Way at any given moment. Some are likely fragments of ancient planets. Others may be remnants of collisions that occurred during the chaotic birth of distant solar systems. Every star system experiences periods of violence. Young planets collide. Massive worlds scatter smaller bodies through gravitational encounters. Comets and asteroids are flung outward into deep space. Over billions of years, these events create an enormous population of wandering objects moving freely between the stars. In a sense, the galaxy is filled with cosmic debris. But debris may be too simple a word. These travelers are records of history. Each carries chemical information about the environment in which it formed. Their minerals, ices, and organic compounds preserve clues about conditions around stars that may no longer even exist in the same form today. They are time capsules drifting through the galaxy. By studying them, scientists gain access to information that would otherwise remain unreachable. Some researchers have even suggested that interstellar objects may play an important role in distributing complex chemistry throughout the Milky Way. Organic molecules have been discovered in interstellar clouds, on comets, and within meteorites. Many of the chemical ingredients associated with life appear to be surprisingly common throughout space. This realization has led to fascinating possibilities. If the building blocks of biology are widespread, then young planets forming around distant stars may begin with similar chemical foundations. The processes that eventually produced life on Earth may not be unique. Instead, they could be part of a much larger galactic story unfolding across billions of years. That does not mean life exists everywhere. But it does suggest that nature may repeatedly create environments where life has an opportunity to emerge. Interstellar objects provide evidence that planetary systems are not completely isolated from one another. Material can travel. Chemistry can travel. Even the ingredients necessary for future worlds can travel. This concept changes the way astronomers think about the galaxy itself. Rather than viewing each solar system as a separate island, scientists increasingly see the Milky Way as a connected ecosystem. Matter moves between stars. Gas clouds collapse to form new suns. Exploding stars distribute heavy elements across space. Planets form from recycled material created by earlier generations of stars. Everything is connected through an ongoing cycle of creation and transformation. The interstellar visitor passing through our solar system is one small part of that enormous process. Its journey may have begun hundreds of millions of years ago. It may have traveled across regions of space humanity has never observed directly. It may have passed near stars that no longer appear where they once were. And now, for a brief moment, it has crossed paths with a technological civilization capable of recognizing what it is. That fact alone is remarkable. A species living on a small planet around an ordinary star has developed instruments sensitive enough to detect and analyze an object born around another sun. For a brief instant, two completely separate histories intersect. Then the encounter ends. The object continues its voyage outward, gradually fading from view as it returns to the darkness between the stars. Eventually it will become too distant to observe. Its secrets will travel onward with it. Yet its passage leaves behind something valuable. Knowledge. Evidence that the galaxy is more interconnected than it appears. Evidence that planetary systems exchange material across vast distances. And evidence that the story of our solar system may be linked to countless others scattered throughout the Milky Way. Perhaps the most important lesson is not about the object itself. It is about perspective. Every interstellar visitor reminds us that the universe is not divided into isolated regions separated forever by empty space. Instead, it is a dynamic and evolving network where matter, energy, and history flow continuously across unimaginable distances. The stars above us are not strangers. They are participants in the same cosmic story. And every now and then, a traveler arrives from another chapter, giving us a brief glimpse of a universe far larger, older, and more connected than we ever imagined.